Hello class, we are group 3. Our members are Christine Chen, Junze Wen, Shaoqing Wen, Raymond Wu, Xiaoke Yang, and Zimo Yang. So here is our agenda. We will first go over three papers one by one and make conclusion or connections of those three papers. And at the end of the presentation, we are open to any questions. I will first talk about our first paper, Do Insiders Learn from Outsiders? Evidence from Mergers and Acquisition. The paper is written by Yuanzi Luo and published August 2005. In this paper, Yuanzi was trying to find out how the market reaction to a merger and acquisition announcement affects merging decision. For example, the CEOs of two companies conclude merger will create value and announce it to the public. However, outside investors are not optimistic about merger decision and express their opposition in many ways. What do managers do in this situation? Do they ignore the market and make the deal, or do they learn from the market and cancel the deal? So in this paper, Yuanzi investigated learning during the mergers and acquisitions. Learning means the managers of merging companies extract information from the stock market reaction to M&A announcement and consider the information in the making the closing. How to test learning. Wenzel developed his own method for testing learning. He first argues that correlation between the market reaction to the M&A announcement and later deal closing decision is not a sufficient proof of learnings, even if it is statistically significant. There are two possible non-learning explanations. They are probability feedback hypothesis and common information hypothesis. The first one is not hard to understand. Suppose two deals will each produce $10 synergy if completed. At the announcement, investors correctly foresee that the probability of consummation is 50% for deal 1 and 100% for deal 2. Therefore, the total value change of two merging companies at announcement is $5 for deal 1 and $10 for deal 2. In this example, a higher market reaction is associated with a greater deal completion probability without learning because the market's expectation of completion probability feeds back into the price reaction to the announcement. The second one, deals are perceived better by both market and emerging companies are likely to have higher market reactions and a better chance of consummation, even if learning common information. So what is his method? Yuanzi's method of testing learnings builds on a regression of the deal completion decision and the stock return around M&A announcement. He used the profit formula, which you guys can see from the slides. Complete is 1 for the completed deals, and 0 for canceled ones, and the tilde represent profit regression relation. Synergy is the total value change if two companies will definitely merge. He estimated synergy before running the test. Triad represent the deal characteristics that are hypothesized to covary with merging companies' incentive to learn from the market. In the simplest case, triad is 1 for the learning sample and 0 for the non-learning control sample. Vector Q consists of control variables. Among all the variables, the interactive triad times synergy is the key term in the equation. This is because if its coefficient delta p is statistically significant and with the predicted sign, no learning is rejected. So there are three testable hypotheses. The first one is companies are more likely to learn in pre-arrangement deals than in arrangement deals. The second hypothesis is companies are more likely to learn in non-high-tech deals than in high-tech deals. The third hypothesis is smaller bidders are more likely to learn than larger bidders. So before talking about any model, let me first explain two figures for the sake of better understanding of the models that I will talk later. For the figure 1, T represents timeline. For example, T equals 1 means the time before M&A announcement. S represents shareholder and M represents manager. V is the estimation of the synergy. For example, VM1 means the synergy estimation of manager right before M&A announcement. Moving on to figure 2, X1 stands for manager's information, X2 stands for shareholders' information, and X0 stands for common information. So we can conclude as T becomes bigger, X0 becomes larger, meaning that there is less information asymmetry as time goes by. Based on two figures, Yuanzi was able to come up with equations for synergy valuation for both manager and shareholders. For example, when t equals 1 right before the M&A announcement, manager's synergy valuation is x plus x1 plus x0, where the x is Yuanzi's estimation of the synergy, which is the universal cross-sectional mean. Similarly, shareholders' synergy valuation is x plus x2 plus x0 at t equals 3 right after M&A announcement. If the manager learned from the market, his synergy evaluation is x plus x0 plus x1 plus x2. If not, the valuation still same as when t equals 1. Based on this, we can conclude x0, x1, xn follow normal distribution. So we can come up with this equation. Sigma m equals sigma 0 plus sigma 1, and sigma s equals sigma 0 plus sigma 2. So finally, here are two models for testing learnings. Proposition 1 compares the slope B in the equation on the left between a learning sample and a non-learning control sample. And the three testable hypothesis is correlates between a pair of samples. Yanzi argues that the slope is higher for the learners than non-learners. Proposition 2 presents a closed form relation among the value of the market signal, market cancellation cost, and the informative of the market. So I will pass over to Xiaoxing for the rest of the paper.
Thank you, Jen. Now I will go over samples and data. The author uses the following market model to get a cumulative abnormal return of a stock by obtaining initial M&A sample mainly from the SDC domestic M&A database, with minor corrections drawn from Dow Jones Interactive. Stock price data are from the CRSP daily files. The author estimates the model between 250 to 50 trading days before the M&A announcement. The final samples excludes hostile M&As, multiple bidder deals. All M&As are by U.S. public companies. The author sets the sample period at 10 years by the announcement date, and the deal value must be at least $10 million. The final full sample contains 2,114 M&As. Table 2 describes the market reaction to the M&A announcement. The author measures the market reaction with the cumulative normal returns of the announcing company over trading days within the interval of 1 day prior to or within 7 days after the announcing day. The trading day prior to the announcement controls for possible delays of published news. The 7 trading days after the announcement allow investors to receive and fully analyze the announced information. According to Table 2, almost half of the M&As reduce shareholder value at the announcement. The value-weighted due returns is positive or flagged only in 54% of the observations. The two sides have very different experience. Only 42 of the bidders have non-negative announcement returns, whereas 82 of the targets gain. Their return correlation is only 0.17. The bidder return dominates the due return because the bidder is often much larger than the target. The correlation between the due return and the bidder return is 0.86. Table 3 and 4 show the relation between the market reaction to the M&A announcement and the later closing decision. The author uses either the combined deal return or individual bidder and target announcement returns to represent the market reaction. Table 3 shows that the due return predicts the later closing decision. For the full sample, the completion frequency is 93% when the due return is equal or greater than 0, but only 90.6% when the due return is less than 0. The difference is significant at the 5% level. Companies complete M&As more often when the due return is non-negative than when it is negative. Columns B to H show that the difference is larger in pre-agreement deals than it is in agreement deals, in non-high-tech deals than in high-tech deals, and in deals with small bidders than in those with large bidders. The results are consistent with hypothesis 1 to 3. Table 4 reports plot-bit regressions of the deal closing on the market reaction to the announcement controlling for deal characteristics. Both taxes A and B are for the full sample, and taxes C to I are for the 7 subsamples related to hypothesis 1 to 3. According to Table 4 Test A, the deal return predicts deal closing decision at the 1% level in the full sample. According to Test B, the bidder's announcement return predicts the later closing decision at the 5% level in the full sample, and the target's announcement return is not significant. The pattern is consistent with the author's argument that the combined deal return is a better determinant of the closing decision than the returns of the individual companies, and the coefficient on the deal return is higher and the corresponding p-value is lower for pre-agreement non-high-tech deals and for deals with smaller bidders, suggests that the evidence is consistent with the learning hypothesis 1 to 3. Table 5 tests the hypothesis 1 to 3 and learning. The author includes control variables for the sake of caution as well as for higher test power. The stock returns before the M&A announcement capture information leakage, and the returns afterward are the proxy for post-announcement information. The dollar signs of the deal and is ratio to the bidder's market capitalization control for any size effect. If the bidder and the target are headquartered in the same state, and if the exchange medium is pure cash, all these control variables significantly predict the later closing decision. Text A to C of Table 5 indicate that the interactive terms early announcement times synergy, low-tech times synergy, and BMV times synergy are all significant at the 5% level. Texts D to E show that variables of early announcement, low-tech BMV have the predicted size and are significant at the 10% level. It's consistent with the hypothesis 1 to 3 jointly and learning. To conclude, the results indicate that the announcement timing, the high-tech status, and the bidder size seem to influence the company's incentive to learn from the market during M&As. In addition to the closing decision, merging companies can also apply what they learn from the market to the decision of renegotiation. The author uses the bidders and the target's return around the announcement as independent variables. In the full sample, 1,561 deals are announced, and 1,458 of them are completed. Cancelled deals are excluded from the taxes. Table 6 shows the relations between the renegotiation decision and deal characteristics. Column A reports pairwise correlations, and B reports a probit regression with the dependent variable as 1 for renegotiated deals and 0 for the others. Among the deal characteristics, only the announcement timings predicts the renegotiation decision, and the relation is strongly significant in both columns. That is to say, offers without a definitive contract are more likely to be revised. Table 7 Text B examines the relation between the market reaction and the renegotiation decision only within the deals that are renegotiated ex post. The author uses the bidders and the target's announcement cumulative and normal returns to represent the market reaction to the M&A announcement. At the announcement, the market likely anticipates the difference in the revision probability between the ex-post renegotiated deals and the ex-post not renegotiated ones, and the price reaction can be more subdued for the former. Text A includes 1,457 all completed deals, and Text B has 94 completed and renegotiated deals. The result shows that the bidder announcement return is significant at the 1% level in Text B, stronger than that in Text A. The target's announcement cumulative and normal returns is positive with a p-value of 10%, indicating that the evidence is consistent with learning in renegotiations. Through Texas, the author comes to the conclusion that companies seem to learn from the market during M&As. The merging companies appear to extract information from the market reaction to the announcement and apply that information to the closing decision. In robustness Texas, the author finds that the bidder's abnormal return around the announcement predicts the deal renegotiation decision. Furthermore, merging companies respond to the market reaction differently and in predictable patterns. The evidence of Texas suggests that companies are more likely to learn when the cost of reneging is lower, or when the market has more information that companies do not know. Lastly, the author expects more definitive evidence on learning to emerge, not only in M&As, but also in other areas of corporate finance. Therefore, the model and the test process of this paper can also be applied to other studies of learning. Now I will pass it off to Jermo.
Thank you. So let's talk about the second paper, the introduction for Gao and Liang study. The name of the paper is Informational Feedback, Adverse Selection and Optimal Disclosure Policy. The authors' names are Pingyang Gao and Jinghong Liang. The year of the publication is 2013. The paper will talk about how Gao and Liang study a model of disclosure with the informational feedback effect. And the motivation for this paper is disclosure have been an important component of security regulation in United States since 1930s. So one major theoretical support for disclosure to a secondary market is that it levels the playing field. However, the same private information also guides real decisions and resource allocation when transmitted to related decision makers. In Gauss and Liang's paper, they study a model of disclosure with the informational feedback effect. On one hand, disclosure raises firms' value by enhancing liquidity. On the other hand, disclosure lowers the firm's value by weakening the informational feedback from the stock price. Therefore, the optimal disclosure policy trades off those two effects on firm's value. Let's talk about the model mentioned by Gao and Liang's study. They start with a model in which disclosure mitigates the adverse selection problem along traders and then incorporate the informational feedback effect. Towards this goal, they explicitly model two key features of secondary stock market. First, some information that is otherwise unknown to a firm can be produced by the market and transmitted to the firm through trading. Second, the firm uses information in the stock price to guide its real decision. As described in Figure 1, all parties are risk-neutral, and the risk-free rate of gross return is normalized to be 1. The timeline of the model consists of 4 days. At day 1, a firm owning a stochastic technology that produces cash flow at day 4 sets a disclosure policy beta and then issue equity shares to the continuous of ACCT identical investor, which is the original investor in the private market at price V. At day 2, a speculator acquires information before the firm disclosed. At day 3, the firm makes an investment decision based on all information available, including the stock price. At day 2. At day 4, the cash flow is realized and the consumption takes place. So in this page, Gao and Liang briefly discuss how the informational feedback effect is operationalized through the information structure summarized in Table 1 below, as shown by Case 3 of Table 1. With probability 1 minus f, the firm does not learn anything internally about mu, but the share price P contains information to the firm about mu, which alternately originates from the speculator's privately acquired signal Y. As a result, the stock price is not randomized source of information to the firm. In addition, in case 1, with probability F beta as preempts the speculator's information advantage Y. Therefore, from the perspective at day 1 when the disclosure policy is made, the information produced by the speculators is correlated to but not a subset of the firm's information. Now, I will pass to Raymond to talk about the result part. Thank you.
Thank you, Zhimo. Now let's talk about the results. In order to understand the results, we can discuss the preliminary analysis first. In this session, we use backward induction to solve day 3 investment decision and day 2 trading gain in order to derive the firm value at day 1. When we combine the two equations below, a fixed point problem emerges. In setting the growth portion of price, the market maker focuses not only the underlying profitability but also the firm's belief about profitability at day 3, which may be affected by price. Actually, the cash flow from the growth opportunity at day 4 depends not only directly on profitability but also on the investment decision at day 3, which in turn depends on the firm's information about profitability in the price at day 2. Now moving on to the next slide. Let's discuss the trading gains at day 2 for the 3 cases listed in the table 1. For case 1, the firm receives a perfect signal and discloses it. The firm does not learn any new information from the price, and both the speculator and the market maker are perfectly informed. Therefore, the speculator is indifferent in trading, only no profit. For case 2 and 3, no disclosure here. The speculator has an information advantage over the market maker. Based on case 2 and 3, we can make some conclusions on lemma 1. We can tell that the speculator buys when receiving favorable information and sells when receiving negative information. Given this trading strategy, the market maker's inference is also straightforward. In both cases, the speculator's private information is compounding into price, making the informational feedback effect possible. When Q is equal to 0, the market maker is unable to infer the speculator's private signal. Thus, the price does not reflect the speculator's private information. This enables the speculators to own a profit. Now let's move to the next slide. Here are more details about the relevant results for the further study of the firm's disclosure choice based on the level 1 mentioned before. For equation 2, the speculator's expected gross profit is increasing in the quality of the private signal but decreasing in the firm's disclosure policy. Also, as expected, it is increasing in liquidity shock, firm profitability uncertainty, and growth parameters. For equation 3, the speculator chooses information acquisition to maximize the net expected profit. For equation 4, because of the zero-sum nature of trading at day 2, the speculator's gross profit is equal to the original investor's trading loss. Anticipating this loss on average, the original investor discounts the firm's shares at day 1 by the same amount. Thus, the liquidity discount in the primary market for the firm is what presenting in the equation 4. For equation 5, this presents the feedback effect at day 3. For equation 6, it increases in the amount of information internally available to the firm and information the firm could glean from the stock price. Anticipating the speculator's information acquisition response and its resulting effects on the liquidity discount and the growth opportunities, the firm chose to disclose to maximize the firm value at day 1. With the information above, we examine in detail the firm's disclosure policy at day 1. Here shows the lemma 2. Lemma 2 is straightforward from equation 3. The speculator's acquisition of signal gives an informational advantage in trading only if the firm's disclosure is not informative. When the firm's disclosure improves, the costly private information acquisition becomes less profitable, and the speculator acquires less information. This reduction in private information acquisition resulting from the firm's disclosure has two opposite effects on the firm's value. It levels the playing field among traders on one hand but reduces the firm's investment efficiency on the other. This is the basic trade-off of the disclosure policy at day 1. You can also use proposition 1 to illustrate lemma 2. Part 1 of proposition 1 is the familiar result that disclosure improves liquidity by leveling the playing field. In this model, disclosure reduces not only the likelihood that the speculator has an informational advantage, but also the magnitude of the informational advantage. As a result, a higher disclosure level reduces the adverse selection problems among investors in the secondary market at day 2, which in turn reduces the liquidity discount original investors require in the primary market in day 1. However, Part 2 of Proposition 1 suggests that a higher disclosure level also reduces investment efficiency because disclosures surpass the speculator's primary information acquisition. The first investment decision turns out to be more efficient when the speculator acquires more information. Thus, the speculator's private information is the final source of the information the firm learns from the stock price and thus generates a positive externality on the firm. Now let's use Proposition 2 to discuss private information acquisition and firm value. The firm value actually decreases in cost if and only if the growth prospect is sufficiently large. When the investment opportunity is important and the benefit of the feedback from the stock price is large, the investment efficiency dominates the liquidity cost and the firm is better off with a lower rather than a higher cost. Next, we can use Proposition 3 to talk about growth and disclosure level. Proposition 3 adds new predictions about the relationship between growth and disclosure policies. On one hand, it increased the marginal benefit of earning from the stock price, inducing the firm to reduce disclosure. On the other hand, a higher variance of profitability also makes the speculator's information acquisition more profitable and increase liquidity costs, inducing the firm to increase disclosure. Moving on to the next slide, we can regard Proposition 4 as an extension of the study. When a firm's internal information is scarce and the market information production is efficient, the information provided to outsiders through the direct channels is dominated by that through the indirect channel. As a result, more disclosure by the firm results in less information available to the outside decision maker. Now I will pass to Zimo to talk about the conclusion of this paper. Thank you.
So the conclusion for this study, disclosure has been an important component of securities regulation in United States since 1930s. One major benefits of explicitly consider the informational feedback effect in the theory of disclosure to second stock market is that it reconciles the joint promotion of disclosure and private information acquisitions in securities regulation. Finally, both recent success and problem of predictions market illustrated the main tension in Gao and Liang's paper. The fact that providing traders with incentive to acquire information is a first-order issue in production markets support their contention. The adverse effects of disclosure on private information acquisition and on the informational feedback function of the stock market can be substantial. Now I will pass to Xiaoke to talk about the third paper. Thank you.
Thank you, Zhimo. Next, I'm going to talk about the third paper, the synergy between accounting disclosure and forward-looking information in stock price, written by Arya Mittendorf and our Professor Ramanan in year of 2017. So what is on this paper? The paper actually developed a model to examine how accounting disclosure affects the decision usefulness of such stock market reaction. To prove information in accounting report can prove useful because it helps observers better to interpret and isolate the decision-relevant information embedded in the ensuing stock price reaction. So what is the motivation of this paper? Stock price provide relevant feedback that can guide the future firm decision. Next, let's go through the description of the model. First, basic setting of the model. The firm developed a new technology that can use internally as well as licensed for external use. The new technology will increase the firm profitability. The firm sells the right to use it to the third-party manufacturer for a manual-agreed price T. The price T is also the cost for the third-party manufacturer. The reason why the firm is selling the rights to the third party, I'll talk about in the later slide. And then the firm established an accounting system for possession age to generate public observed accounting report or acts. So the accounting report is a role of accounting disclosure. Even though accounting disclosure cannot tell everyone a newly production is whether success or not, but it can provide information pertaining up to profitability of the existing product lines. Since accounting reports are not only source of information about the firm, the stock price aggregate or information about the firm, including the forward-looking information about the prospects of the newly introduced technology. Let's go through the setting of stock market in the model. Following Kyle, the firm equity market consists of this informed trader, some liquidity traders, and a risk-neutral market maker who sets the price. First, informed trader place market order Z for the firm's share, and its goal is to maximize their expected trading profit. Then, liquidity trader U is a quantity demand by the liquidity traders, and it is uncorrelated to all other variables in the model. Then, a market maker observers aggregate order flow for the firm share to set the price P to break even in expectations and provide the liquidity necessary to clear the market. And then there's a question for this model. How disclosure about the current activity can influence the way in which market price can inform future decision. By solving this question, model sets the firm utilize the third party to make the future productive decision. This permits the third party to take full advantage of the information feedback from the firm's stock price, while allowing the expected benefits of such feedback in future decisions to be fully recognized in the contract. This is the reason why in this model, the firm is selling the rights to use a new technology to a third party. The sequence of the all events follow the timeline for this model. First, firm establish accounting system to generate report. Then the firm sells the right to third party. After report are issued and the market price P set, we can see the reaction of third party based on the information feedback from the stock price and the accounting disclosure. In the end, terminal payoff for the firm and the manufacturer realize and consume. The result of the model comes out. Next, I'm going to pass to Christine to discuss the disclosure policy in the model.
Thank you, Xiaoke. Next, I'll talk about disclosure policy. Disclosures about existing activities can facilitate learning about a new technology and improve its use and profitability. There are a few disclosure policies mentioned in the readings. The first one I'll go over is equity market equilibrium. A stock market reaction gives us information on the next technology. By using R to demonstrate as the firm's report, it is trying to see if it can facilitate feedback from the stock market. And with proposition 1 given on the left, report R and stock prices P interact and can give us useful information on manufacture in deciphering the prospects of the new technology from stock price P. Ultimately, through this proposition, we can see that with traders and investors holding the firm's information, it can reflect the stock price as it can sense how well the firm is doing and vice versa. The greater the information is given, the more the market maker waits. The next disclosure policy I'll go over is exploiting the new technology. When the new technology prospects are great, the stock price reflects optimism, and when there's a positive market response, manufacturers make more use of the new technology. More precise the accounting report is on the existing technology, the more precise the manufacturer information about the new technology. It also reduces the amount of confounding information in price about existing technology and it reduces the amount of noise, which is the uncertainty about stock prices. The more potential learning the manufacturer can glean from market price, the greater the value of the technology itself. So the last disclosure policy I'll go over is public disclosure versus private dissemination. It's basically the test between privately exposing information or publicly announcing the information. Public accounting reports of current business can help intensify the decision usefulness of private information embedded in equity prices. The report is less valuable when communicated privately than when disseminated publicly and has a wider ramification on the firm's accounting policy choice. In private communications, the firm requires and communicates less information, and expected firm value is actually lower than when disclosing publicly. So some additional considerations are trading markets with an informed investor can influence decision and how accounting reports on current operation and facilitate inferences that are drawn from stock prices. There are other sources to be looking at other than stock prices. For example, the firm's forecast, analysis report, macroeconomics indicator, and the more information available to guide the manufacturer's choice, the greater the technology value, and thus the greater the firm value, and the firm value will tend to increase. The key to promoting investment is that equity market participants have some private information useful to decision makers and is rather to be announced publicly than privately. To sum up the overall paper, this paper gives us a deeper dive in between information contained in accounting reports and in stock prices. Accounting represents value-relevant events by incorporating information about the results of current and past decisions, which leads to possible future information being deduced. Accounting reports provide no direct information to guide future decisions, but reports have been proven useful because they help observe better interpret guidance for decision making embedded in stock prices, and by reducing uncertainty about the profitability of a company's current technology, accounting disclosure make it easier to sort out information embedded in equity prices that can help guide decision about newly developed technology. And to wrap up our whole presentation, the three papers summarizes that by using the market response, companies are able to grasp better knowledge on their firm's performance and how they should go about in making future decisions. Stock prices give us a lot of useful information, and by observing the market participants, we are able to find intriguing results. The stock price is an efficient indicator for firms to indicate the company's value, and when merging companies, it appears to extract information for the market reaction to the announcement and use this information to close decisions. Publicly disclosing information has shown a greater value than privately passing information. By publicly announcing information, there are more fair levels of grounds for everyone to play.